All right. So while you're getting the presentation up, right? Yeah. I just because there are different ways I can do the talk. I just wanted to make sure I understand how many of you here are computer science background. Okay. So about half. So I'll try to. So there are two ways I can do the talk, more from a computer science, artificial intelligence, or also just the opportunity ahead of us in applying computer science and artificial intelligence to agriculture. So I'll try to straddle both of them. Yeah. So I can just introduce myself. So I'm Gargi Dasgupta. I head IBM India Research Labs, IBM India Research Labs spread across Bangalore, Pune, and we also have a small segment of folks working with us in Singapore. So we are really the research unit for IBM to help kind of forward science as well as work on strategic areas that are relevant to the country and to the company. So what we'll do is we'll start with a little bit of the global what it means to be in research and what we do, and then we'll delve into how we are using in the lab, working with our university ecosystem, working on some problems like using artificial intelligence to do precision agriculture, to actually trace the quality of food that comes from farm to sits right at your table. And I'll also touch upon why waste management, sustainability are important topics that you guys should be starting to think about today. And some statistics on why wastage is such a huge problem in the retail industry, and what can tech do. So IBM Research is actually spread across 12 locations in the world. And like I said, our mission is really to forward science by working with our industry partners, academia, and as well as specifically for IBM. So if you look at India, like I said, is spread across Bangalore, Delhi, Singapore. Really our expertise is in artificial intelligence. We work a lot in hybrid cloud, as well as application of artificial intelligence to areas like agriculture, supply chain. And that's what I'm going to talk about primarily today, but just a little bit so that you have a little bit of deeper level of detail. Something you want to? Sorry? No, that's not my phone. Yeah, so a little bit deeper into what we do. We specialize in really 7 areas, all right? And I'll be talking a little bit about agriculture and retail to you today with the aspect of what can artificial intelligence do to transform us into a digital agriculture world, and also how can we solve optimization problems that help in enabling a better supply chain in retail. But there are several other things we do. For example, we work on hybrid cloud, and we try to see how can AI actually help customers move from their legacy monolithic applications trapped in data centers more into more cloud-enabled, agile microservices. Can AI actually read code and do that refactoring for us? We work on blockchain. Blockchain is, if all of you are aware of, is really the technology that enables multi-party collaboration and networks to come together with a shared vision. They might have their own ideas of what privacy, what trust they want, but if you come on a blockchain network, you can actually get traceability and non-refutation. Okay, so that's a technology that we major in my vision of how we can get from a seed of corn grown in a farm to the corn that comes in salad on your table at dinner. Blockchain is one of the enabling techniques that can actually help realize that. We work, of course, needless to say, a majority of our lab focused on data and AI, and which is really about fundamentally pushing AI algorithms, but also understanding the data that drives many of these AI decisions, right? And how can you use AI for enabling transformation, quality understanding of the data itself. And then finally, the last two are interactive, just like I'm talking to you. A lot of the technologies that you have on your phones at home, the Alexas, the Siris, the Google Homes, are interactive. So what does research in speech recognition, the best voice recognition system, video recognition systems, how does research look there? So that's what we do in interactive AI. And the final is something that is very core to humans, reasoning. So you can have the best speech recognition system, but the ability for a human to take the judgment or take the decision, like a doctor deciding whether a cancer treatment is to be meted out to a patient or not, is where reasoning comes in. And reasoning alone cannot be all neural. So I know we are all hyped up about deep learning and neural models, but there needs to be a fair bit of symbolic reasoning as well. So how to marry neuro-symbolic to get to the next level of precision on our artificial intelligence models is what we work on. All right, so just moving on. Today, though, for us, I'm going to talk about how AI can affect an industry like agriculture. And AI has affected many, right? Today, for the last 2-3 days, you've been hearing about medicine, you've been hearing about law, industrial automation. There's nothing that AI cannot touch or should not touch. But there are a little bit of fundamental breakthroughs that I wanted the audience to be aware of, because a lot of times the application in an industry is driven by fundamental breakthroughs. So the fundamental breakthroughs I want all of you to be aware of is really breakthroughs that have happened in speech recognition systems, right? So all of us use Alexa, the Siris. Voice recognition and speech transcription errors are at an all-time low, right? And they've been, of course, made possible by this whole area of research on deep learning. But it's a great field and a great area to be in. 2018 onwards, natural language processing systems really really grew up, I would say. So speech recognition and video recognition were doing well. Natural language processing really became the 2018, where we saw a plethora of vector models. Word2Vec was the precursor, but really Elmos, the BERTs, and several tasks like reading comprehension. Can a computer understand what a passage means? Can a computer answer a question? We call it question answering. Can a computer debate with you? If you guys are interested in the technology, OpenAI released a GPT-2 model, which can actually write a story, right? So not predict what's the next word, not predict what's the next sentence, but really complete a paragraph. So search for unicorns and OpenGPT-2, you'll see the kind of context that machine learning models are now being able to understand and recreate in generative models. So a lot of breakthroughs have happened, right? And object detection, videos. We had this great task on ImageNet, the ImageNet task was really about classifying an object, taking an object and saying what's the species of the dog, flower, cat. The error rates today are below 2% in ImageNet classification. But that hasn't stopped the community from putting more and more research on harder problems, right? Harder problems like object detection in a more complicated setting. Like look at the football player, right? If I have to detect what's the field, what's the player, what are the teams, much more complicated task than a classification task, which looks at an image and says, okay, this is the primary object of interest. So a lot more interesting tasks coming up, and all of this relevant in the context of agriculture. Segmentation, can I take a complicated scenario, use context information and segment it? So all these breakthroughs really help you go deep into an area. And today the area that we're going to talk about is agriculture, right? So what's the state? It's a 2.4 trillion global industry. There's always the need to put more food on the table, right? The need for increasing yield, increasing food productivity, very, very high. At the same time, we have challenges like climate change. And we are in a country like India, where if we increase the productivity, it's not just to put food on the table for a billion people, but we also push our population above the poverty mark. And a majority of our population really actually invests in this in this livelihood, right? So agriculture is a very, very natural fit for a national problem at scale, and technology should be an equal partner in solving these problems. But before we apply, and a lot of people are doing that. By the way, there are a lot of startups that actually work with farmers on issues like precision farming, being able to work with them, give them forecasts on what is the right time to harvest their crop, on what is the right pesticide to apply. But we have to do this at scale, right? If it's got to make a difference, we have to do it at scale. So what are some of the prerequisites that scale needs, right? First of all, we have to see what's the data that's available. What's the planetary data, which means, data of landforms. Let's focus in India, right? Where are the agricultural vegetation? What's the health of those vegetation, right? And so, which means we're talking about massive scale data, right? And it's not just about the landform data, it's the soil data, which is both surface level as well as subsurface level of soil data. It's weather, right? Weather is a big predictor in the business of agriculture, of irrigation, of overall productivity. So what I would like to say is that for you to take away is that in order to solve this problem at scale, there's really petabytes of data. The volume is really, really huge, right? It's not a machine learning model that I can run on my computer or maybe even on my GPU. So it's massive scale data, and the data needs to be on a platform that actually knows how to deal with the data from different farms. For example, all the farms in Karnataka needs to roll up to all the farms in the southern region and finally roll up to all the farms in India, right? So there's a lot of integration, so there needs to be what we used to call in the good old systems ETLs, right? Extract, transform, load. Functions on that platform to be able to integrate, contextualize, be able to search, right? If I have to search what is the NDVI for little 1 hectare by 1 hectare plot that I have, in the districts, in the rural districts, I need to be able to search on that platform. Today, creating even an index or being able to query data at that scale is not possible. But we need to do that, without which, artificial intelligence is not going to be possible. So the good news is, thanks to, associations like NASA, and several others, there's MODIS, Sentinel, there are several high-resolution, multispectral imagery data sets that are available today. Yes, they're available in fragments, but they are available. So the top 3 are really, very, very high-resolution landforms kind of data. And they improve these data sets. These are updated. Now, the lower row is really additional data beyond landforms. So these constitute the weather data, and I'll talk about who collects weather data and why is it so important. There's also soil type data. What's the binding of the soil? How deep is the soil? How moist is it? And very important for agriculture. Without these, any model that you build just on the landforms data is not going to be effective. And the final thing is where AI really flourishes is the historical data. What has historically grown well on this piece of land? What was the yield, 6 months from now? And what was the pattern? What's the seasonality of the crop? So a lot of domain knowledge for agriculture is also needed. So really 3 things: landform data, weather data, soil data, along with all the historical know-how or what we call domain knowledge. Weather data, all right? So who collects weather data? There are many people who collect this. I have, of course, put up an IBM point of view, but don't read it as the weather company, the TWC platform, but there are many players who are beginning to collect weather data. And the scale is really, look at it, 350,000 personal weather stations, 50,000 flights a day can actually send you signals as to what's the atmospheric pressure. There are IoT devices from about 40 million of those. So, this creates a backbone for us to do something that is real and not just a POC, of a predictive model. So this is really the value of and problems that, okay. So let me actually get to the real. So take it. Given that we lost a lot of time, I'm going to focus on the AI problems. Sorry, oh, all right. Let's yeah. So at this point, take it from me that I said there were three things that were needed. There were data at scale. Data at scale is present. Platforms are getting there, right? So we saw the readings. So the question is, what's the AI that one can build? And these are some of the AI services that we have been working with the government of India and other places to build. So the first one is crop health. Can you, from the remote sensing data, which is really about images and landforms, actually figure out what is the crop health or an NDVI at a sub-acre hectare resolution? And this is very important because I didn't get time to talk about India. In India, the challenges are lots of small farms, the average size of a farm is 1 hectare. Lots of small farms, lots of different types of crops grown on those farms, and really a lot of just the remote sensing data will not cut it, right? So on top of the remote sensing data, marrying weather, very accurate weather forecast, and the soil moisture data, you can come up with very precise monitoring of a crop health. And of course, it has to be today done crop by crop, like you do it for tomato, you do it for corn. But hopefully, the hope is that can you abstract that to a group of crops? The next one is moisture level. I mean, as you can imagine, the soil moisture predictions will go a long way in deciding your farming practices. Can you do irrigation? Should you do it today? Should you actually apply the pesticide when it's going to be rain-washed tomorrow? So there are many, many services that we can build, each of them fundamentally supported by AI models, yield quantity and quality estimation. Imagine how important this is for a government to actually predict the price. Price prediction is an age-old problem. We worked with the Karnataka government to do price prediction of tomatoes because we were very, very precise in estimating the yield, right? So bunch of use cases can be applied to India's specific context, right? If you see, like I said, the average size of a field is probably 1 hectare, very, very small fields. Lot of variation. The third variability that we are all happy about and sometimes not so happy about, monsoon clouds, right? So marrying all of that weather data, what you can give to not to farmers, but really to the overall ecosystem is that there is a little region in Haryana which seems to be getting some stress on water stress, and there is a moisture level that is declining. It's time to intervene and take some action. So some of those actions, again, I'm playing this out. What are some of the actions? So for example, if your models predict a very, very low health score, plus you have a low soil moisture, it's possible that that's a pest disease, right? So intervene with a pesticide, possible. Low NDVI, high soil moisture, maybe the area is waterlogging, right? So send someone into there to make sure the water is taken out. So different use cases, right? But all kind of culminate into these kind of results. I'll show you. Right, so with the Gallo winery, we worked on predicting their soil moisture and yield, and actually the yield of the grapes increased by 50%. Right, so this is the kind of difference. I didn't put up the government of Karnataka results. We're still in the second phase, but similar results, improve productivity by 25%. So I'm going to little bit. I'll just say one more thought, and I'll see how much time I have to talk about waste management. But so now hopefully I've given you a sense that there's enough data, there's enough platform building at scale, and there's expertise in AI to be able to say what is the risk of a crop, what's going to be the yield of a farm, right? So we have these models. Now you marry that. So you assume you have these indexes from little tiny bits of farmlands, and you persist them on the blockchain, right? And the use case is a corn and tomato grown in India, packaged in Singapore, and create a salad getting shipped to Malaysia, right? So with that use case, this is what you can actually create. So the colors really are the, let's say, the health indexes of all these crops, and I know them from on a sub-hectare granularity. They pass into any other nation which is processing it, and the spinach and the corn and the tomato get mixed to produce a salad that's going to land up on your table, right? But the risk indices have a different interplay, right? If I had a moderate risk with tomato, just by mixing it with a high-risk item like corn, I'm going to create a salad that's really highly risky, right? But you can actually track this. You were never able to do this. Track this through inter-country boundaries, through the processing, the packaging, and there are contracts that in blockchain, so this is how it gets multidisciplinary. You can marry blockchain onto this platform where we were able to create our models and say that this package of salad really not safe for consumption and should not make its way into the supermarket, right? So that's really the power of getting together technology. So I wanted to talk about how AI can make lives better for agriculture, for food. So these are the types of things we've been doing. There was a very, very important thing that I wanted to talk about was waste management, but I'm not going to have time. But I'll leave you with this thought, right? We all, as good citizens, we all have to think about waste management. And waste management can be in various forms. I focused on the waste management and supply chain. And if you see the whole retail business, again, overall in the globe, it's about a 1.4 trillion. For India, it's 2.9 billion, all right? But look at this. Every year, 12 tons of new inventory unsold gets burnt. Why? Because it's a fast-moving industry. It has low sell-through rates. We don't know what we are building. We don't know how to predict, right? So every year, we're creating that much of, damage to our own environment. And this is where, yeah, I think what my talk, the second part of the talk was really about how can you use artificial intelligence to do better demand forecasting of what is it that is going to sell and reverse the low sell-through rates and turn fashion into a high sell-through rate industry. Okay, but I don't think I'm out of time, right? Let's do that. Yeah, let's take questions. Absolutely. First of all, I think I've shared the charts with the organizers. I'm on LinkedIn. All my departments that work on fashion, supply chain optimization have public pages. So look for me, Google for me, and then you should be able to find more information there.